Hello students, this is lecture number 4 of motion in one dimension, and the topic of today is acceleration and retardation. What is acceleration, what is retardation, that we are going to study in this video. And you will find after watching the whole video that actually acceleration and retardation are the same thing. The only difference is there of the sign there. Theoretically it is different in sign, but how is acceleration different from retardation practically, that we are going to study here. So first we'll take the topic acceleration. What is acceleration? So the theoretical definition of acceleration is change in a velocity with time. Change in velocity with time. This is called as acceleration. Now remember, a body possesses initial velocity as well as final velocity. Okay, so there is a sign convention for it. Initial velocity is denoted by u. According to the sign convention we are taking it, and a final velocity is denoted by v. U and v. U for initial velocity and v for final velocity. So according to this formula, according to this statement, what is there? Change in velocity. So let us suppose here that v is greater than u. Okay, so we can write it as change in velocity is equal to v minus u. Okay, that is just an assumption that final velocity was greater than initial velocity. So in that way we are taking, so change in velocity is v minus u, and time, you know, time is taken in seconds. In seconds we have to take time. So overall what comes for acceleration is, acceleration is equal to v minus u by, here instead of unit we are, let us take it as t only. Okay, here instead of seconds we are taking time as t only. Then we will write the units later on. We will derive the units later on. So time is taken as t. These are the variables that we are taking, and change in velocity, final minus initial, we are taking, assuming that final velocity was greater than initial velocity. So v minus u and t. And now let us take an abbreviation for acceleration also, a word for, a letter for acceleration also, which is normally taken as, you know, it is taken as a. So a equals to, what I am doing, acceleration a, v minus u upon t. I hope up till here you won't have any confusion. Okay, before I rub it, let us see what we did. First we wrote the theoretical definition of acceleration, change in velocity with time. So we took initial velocity as u, final velocity as v. Now we took the change in velocity, assuming that final velocity is greater. So change in velocity equal to v minus u, time is taken as t. Then what we did, acceleration equal to change in velocity upon time. Instead of acceleration, what we have written, a. We have denoted acceleration with a. Now after this what will happen, see, I will continue from here, a equal to v minus u by t. From here I will continue. So a equals to v minus u by t. Let us take t from the denominator to the LHS part, so it will migrate in a crossway, so it will go with a, implies at equals to v minus u, or taking v alone, what we can write, at plus u equals to v, which can be written in a standard form as implies v equals to u plus at. Actually this is your equation for laws of motion. So from here what we can conclude is, we can conclude that final velocity is equal to initial velocity plus multiplication of time and acceleration. And if simply you want to write acceleration, so acceleration equal to v minus u by t. In that way also you can write. So acceleration is the change in velocity with time. In this way we have derived Newton's first equation, which is v equals to u plus at. In why I have derived this equation, so because this equation you are going to use for your numericals. What they will give you, they will tell you that a body initially moving with this much speed, for time this much, if the new velocity is this much, calculate the acceleration. So they will give you final velocity, initial velocity and time. Then they will ask you what is the acceleration, or they may write that the initial velocity of a body is this much, if acceleration and time are this and this, then what will be its final velocity. In that way also they can ask you a question, or straight they can ask you what is acceleration if final velocity equals to this much, u equal to this much, and a body was in a motion for this much times or this much seconds they will give you. So acceleration can also be derived from in this way. Okay, so this is your way to derive acceleration, and this is your Newton's first equation. This we will derive in the part number C of this chapter. Don't worry for that. We will derive all the three equations of motion. But here, why I have derived this first equation? So that you can solve the question which are based on acceleration. This equation is also used when we are getting questions on Newton's law of motion from three equations. But here, what the use of this equation is, we want to calculate acceleration. If in this way, if in a simple way it is available, then write it like this. If it is given in the form of final velocity, initial velocity, time and all that, in this way also you can write, or you can substitute all this value here also. Do not think that if you are not getting acceleration straight, so you need to use this equation. No worry for that. Here also you can place it. Suppose acceleration is not given, or final velocity is not given, or u is not given. If any of the term is not given, place it here as x, y, z, or keep it as a variable only. Let us take it as v only. Suppose, let me give you an example. Suppose acceleration equal to 2. We are just taking it as the numerical value I am giving you. Newton, unit I will derive after this. I will give you the equation, formula for that, how to derive the units of acceleration. So here we are just taking numerical value. Suppose a equal to 2, v equal to 4, and u equal to 6 is given, and they are asking what is the time. So no need to go for this equation, no need to go particularly for another equation. If you can remember this equation, you can get answer from here also. How? See, just place the values. Implies a equal to 2, so instead of a write 2, is equal to v equals to 4, so write 4, minus u is 6 upon t. In this way also you can do it. Now what to do? Just take t here, implies t equals to 4 minus 6 by 2 equals to minus 2 by 2. All the times not in negative, time frame taken as negative. So what we will take? We will take 1 second as answer. Okay, whenever you are in this situation that you are getting time or something in negative which is actually not in negative, then what we do in those type of questions, we neglect the sign, because you know that in physics you get answer in negative when there is change in direction. So because of that we always neglect negative sign. This was just an example to show you that you can use this equation anywhere. Okay, no need to go particularly for this equation. This is the derivation of first law of motion. But even if you don't know this equation and you want to solve question, you can solve by this also, if it is based on acceleration, final velocity, initial velocity and time. So I hope this part is clear. Acceleration is change in velocity with time. Now what we are going to do is, we are going to take out the unit. How to take out the unit for acceleration? It is different from your speed and velocity. Most of the time what is the mistake that is done in the examination is, we are not able to differentiate the unit for speed, velocity and acceleration. So student will write it as meter per second. In the same way they write for speed and velocity. So here we will derive it so that you won't have any confusion. See, acceleration equal to v minus u by t. Okay. Now do not think that velocity meter per second then minus u equal to meter per second. So meter per second will get cancelled and you will get nothing. No. Take it as a whole quantity. If you see this v minus u, what is coming out from here? You are getting the speed, you are getting the velocity. Either think in your mind as speed or velocity, and you know whatever answer you will get from here will be meter per second. In meter per second you will get it, whatever be the answer. Suppose 8 minus 4, so 4 meter per second. 10 minus 2, 8 meter per second. So you have to think only about the unit. So from here, from the expression v minus u, you are going to get meter per second, and for the time seconds. Now the same thing, acceleration equal to, see, meter was in numerator, still in numerator. Per second was there in numerator and still in numerator, but this second is going to migrate from your denominator to numerator, and second will become per second. So there are 2 per seconds there, means second minus 1 was already there, and one more minus 1 it will get because of this s. So minus 1 is equal to meter per second square. Okay, so the unit of acceleration is meter per second square. So wherever in the question, if a quantity is shown with the unit meter per second square, then it will be definitely acceleration or retardation. Retardation we'll discuss after this, but remember that you can identify a quantity only by looking at its unit. For example, see, if I write 26 centimeter cube, so definitely if you have a little knowledge about the units, definitely you will say it is volume of a body. It may be any body, but definitely by looking at centimeter cube, you can say that this quantity is the answer for any body's volume. Okay, and 80 meter square, so definitely it's an area. So with the help of units, you can identify a quantity, what quantity it is with the help of unit. But for that, you should be accurate about your unit. You should have the knowledge of units. So acceleration's unit is meter per second square. How? We have derived it from here, meter per second upon second. So second will migrate, it will become meter per second square. In the same way, you can write kilometer per hour square. Okay. That question normally we don't get normally questions on kilometers and all. Mostly the questions in physics are for meter per second square only. Okay. But if you want to derive, you can derive that also. So meter per second square is the unit for acceleration. Now what is retardation? Retardation is also change in velocity with time, but it is negative. It is shown as negative. For example, if I write minus 20 meter per second square, this is also a type of acceleration, but since a negative sign is shown here, what you will say this is retardation. Now let us see practically what is retardation. What is practically retardation and what is practically acceleration, so that you will have a clear concept regarding both these things. So we will take a single example for both. See, you are riding a bike. You are riding a bike somewhere. Suppose first case is you are on a road which is not at all crowded. So what you do? You increase the accelerator of your bike. It means speed gets increased. Speed gets increased. So when speed increases, that you will get from the speedometer. When speed gets increased or speed is increasing, that is called as acceleration. Means change in velocity is there, but it is positive. Means it is increasing. Positive here means increasing. If speed is increasing, then you will say that this is acceleration. But suppose suddenly you get into a crowded place, then what you will do? You will decrease your speed. You will decrease your speed means you are decreasing your acceleration. Means this time you are not going upward. This arrow won't go upward. Means this time the speed is like this. Speed is decreasing, and whenever there is decreasing speed, it means that negative acceleration, which is also called as retardation. These are simple things. This is not a rocket science. Simple thing. This is practically from your life. When you are riding a bike, when increases the speed, that is acceleration. When you are decreasing the speed, that is retardation. That is why retardation is shown negative. Negative means definitely the body's speed is going to decrease from the current condition. Suppose it is at 80 km per hour speed. Suppose the bike is moving with 80 km per hour speed. So if there is written somewhere that there is retardation there, now retardation process has started for this vehicle, definitely now the speed will be less than 80 km per hour, because it is itself mentioning there that the body is retarding. But if it says the body accelerates, then definitely speed will be greater than 80 km per hour, because the current situation is this one. That is why retardation is shown as negative. That is what I told you, that acceleration and retardation are the same thing. But what is there? Theoretically we show it with a negative sign, and practically it means that the speed is decreasing. Speed is getting decreased. So when you are going to use retardation in your mathematical questions, the numerical that are in your book, there for retardation we won't use simple number. If it is written that the body is getting retarded at the rate of 10 meter per second square, so in the numerical we will write it as minus 10 meter per second square. Keep this thing in your mind. If retardation what is mentioned there and a value is given 10 meter per second square, so in the numericals we have to use minus 10 meter per second square, because it is clearly mentioning you that it's a case of retardation. So I hope acceleration retardation is clear to you. If speed increases, the body accelerates. If the speed decreases, the body decelerates, or it is also called as retardation. So I hope acceleration retardation is clear to you, and I hope you can write examples by yourself for this question. Now, what is uniform acceleration? Uniform acceleration most of the times is confused with your constant acceleration. We think that constant acceleration is constant in that way. Uniform means it is increasing at a particular rate. For example, see, suppose this is a condition 0 0, time 0, speed is 0. Take this condition. So suppose in first second the acceleration was 10 meter per second square. In the second second it was 20 meter per second square. Third one 30 meter per second square. So what you are noticing is that for every second there is an increase of 10 meter per second square. 10 meter per second square. For every minute, for every time interval, it is getting increased by 10 meter per second square. That is called as uniform acceleration. It is that much simple. If a body accelerate at a constant rate, that is called as uniform acceleration. For 1 second, 10 meter per second square. For 2, 20 meter per second square. So uniformly the speed will increase. It won't increase suddenly, it won't get decreased suddenly. Slowly it is increasing. That is called as uniform acceleration. In this way you can also write for uniform retardation, take the reverse of it. Take the reverse of it. In the first second it was 30 meter per second square. In the second second it was 20 meter per second square. In the third second it was 10 meter per second square. Clear? In that way you can write for uniform retardation also. With this example we can clarify both your uniform acceleration as well as uniform retardation. It is very easy. That is why I said to you that if one part is clear to you, second part will come by itself. So uniform acceleration means first second 10, second second 20 meters. So 10 meter per second square is the increasement, okay, for every time interval. But what about uniform retardation? When 10 meter per second square is in this way, decreasing. Initially 0 0, sorry, not initially 0 0. We cannot take initially 0 for retardation. So suppose at first second it was 30 meter per second square. Okay, in the second second it was 20 meter per second square. In the third it was 10 meter per second square. So what you are noticing is finally it will get to 0. So what you are noticing is for every second it is getting decreased by 10. 30 became 20, 20 became 10. So that is uniform retardation. Now what about variable retardation or variable acceleration, which is also called as non-uniform acceleration. So for variable what you will do is see, same example, 0 0. This is your time and this is your, sorry, not speed here, kind corrected, this is acceleration. Acceleration, okay, 0 0. Now suppose in first second the acceleration was 2 meter per second square. Okay, in the second second it was 6 meter per second square. In the third it was 8 meter per second square. In the fourth the body reached a highway and now the acceleration is suppose 20 meter per second square. Acceleration got increased. Okay, so what you are noticing here is you are noticing that there is acceleration. Okay, there is acceleration, but it is not in a uniform way. Sometimes increment is 4, okay, here it's 2, here it's 12. So this is not uniform acceleration. When acceleration is there but the increment is not in a way, in a proper way, it is a variable. That's why the word is variable. Variable means, I told you in the last video that variable word wherever is there it means changing. So changing acceleration, acceleration is not fixed, the values are not fixed, they are not increasing at a constant way. In a proper rate they are not increasing. So it is increasing but not in a proper way. As here you know that for every second there is 10 meter per second square increasement, but here you cannot say that there is 4 meter per second square increasement every time. Why? Because here it was 4, then it became 2, and then it became 12. So such type of acceleration are called as non-uniform acceleration or variable acceleration. Now I hope you can write it for variable retardation to the reverse. First second 20 meter per second square. Okay, second second it was 8 meter per second square. In the reverse way also you can take the example. So from these two examples what we did, we clarified our doubts regarding uniform retardation, uniform acceleration, non-uniform acceleration and non-uniform retardation. But remember, whenever retardation is there, numerically you have to take negative sign before the given measurement. Whatever the quantity is given, negative sign you have to take. Now some more points which comes for one word in your examination is, remember that there is a term, first we will discuss this, acceleration due to gravity. What is acceleration due to gravity? There is acceleration, there is retardation, but what is acceleration due to gravity? So remember that whenever you freely leave a body, it is not tied with a thread, it is not connected somewhere. Suppose it's a cricket ball and you are at the roof. So when you leave a body, the force with which earth attracts it towards itself, the gravitational attraction of earth, that is called as acceleration due to gravity, which is produced in that body. The acceleration that this body is going to receive due to earth's attraction is called as acceleration due to gravity. And remember that acceleration due to gravity does not depends on mass. Suppose this is mass number 1 and this is mass number 2. So when you will allow it to have a free fall under gravity in a vacuum, okay, so what will happen? These two bodies are going to reach to the surface at the same time because they are at vacuum. So this acceleration due to gravity, which it proves that acceleration due to gravity does not depends on mass. Okay, in a vacuum also it will work, acceleration due to gravity will work, but since it is vacuum, so that body won't feel that mass. Okay, so it is not at all dependent on mass. So remember that when two bodies are dropped in a vacuum, this question is a repeated question for examination. If two bodies are allowed for a free fall under vacuum, which of the two bodies is going to reach faster if mass 2 is greater than mass 1? So normally what you will think, mass 2 is greater, so it will reach faster, and you will write answer as this one, greater mass. No, in a vacuum both of the body will reach to the surface at the same time. And acceleration due to gravity, again, what is the theoretical definition? The force with which earth attracts a body, it creates an acceleration in that body, and that acceleration is called as acceleration due to gravity. The acceleration produced, acceleration produced in a body due to gravitational attraction of earth, that is called as acceleration due to gravity. Another thing, does not depends on mass. Another point which comes for 1 mark is, it is maximum at poles and minimum at equator. These are the points which comes for 1 marks. 1 mark question can come, does acceleration depends on gravity or not? Or a question like this, free fall, two bodies are falling, which will reach faster? Or this question, what do you mean by acceleration due to gravity? Okay, and where is it maximum, where it is minimum? These type of questions are there from your acceleration and retardation part. Okay, so let us conclude what we studied today. First we studied about acceleration, then we took out its expression. Here we studied about the definition, then here we got the expression A equal to V minus U by T. Then what we did, we took out its unit. Then after this what we did, types of acceleration, it can be uniform, it can be non-uniform. Okay, after this we went to retardation. What is the theoretical definition of retardation that we studied here? Negative acceleration is called as your retardation. Okay, then expression same as here, expression is same as acceleration, but as I told you, you have to use negative sign there. Okay, if acceleration is like this, okay, means for acceleration it was V minus U by T, and if acceleration is minus V minus U by T, the negative sign here means that this acceleration is retardation. Okay, next what we did after this, we studied about uniform acceleration and then non-uniform acceleration. Again I'm telling you, keep in your mind, non-uniform is also written as variable. So variable retardation or variable acceleration. Okay, so in this way you have to give answers of the question if these questions are asked in your examination. So I hope these things which I wrote at last are clear to you. If they are not clear to you, again I'm telling you, believe your text more than videos and more than any of the classes that are given to you, the more accurate things are your textbook. So whenever you have doubt for something, go back to your textbook first. They will give you the correct answer there. Okay. So I hope all these things are clear to you. Till then, keep going, keep studying. Thanks for watching.